A little bit.
I think it's hysterical.
If there was another way I could do it, I would, but it's just easier. All right. Now, if you add these two together, 30 plus 35, that always equals the mass. Inside the nucleus, so you guys are standing in the middle there, that's all of the mass. The entire mass of the atom is jammed into a little tiny nucleus. Outside the nucleus, those are your negative electrons, right? Those have nothing to do with the mass. Okay? So that's why it works every time for every atom, every ion, you subtract them, you get the neutrons. It makes sense because the mass is protons plus neutrons. Okay, so anyways, good job, Z. The entire atom is neutral. Zero charge. 30 negatives, 30 positives cancel out. The nucleus, however, is plus 30. The positive, the nuclear charge would be positive 30. Okay, who wants K plus? Zeke, if you were going to pick on somebody, who would it be?
Whoever wants to go.
Nice, nice. Man, thanks for volunteering.
You're welcome. 19.
19.
20.
20.
And 19?
It would be 19 if it was neutral, but it's not neutral. This plus 1 is telling me that the total charge of all of them is plus 1.
So it's 20.
I don't know. You don't seem confident. So so the reason I had us use the paper again there, and it's not easy, so don't feel bad. Okay. All right. So don't get embarrassed. This is when we're first learning it, it's a little confusing. The best way to explain it is if you see a positive 1, 2, 3, whatever this charge is up here, that means there's more protons than electrons. So positives win. If you see a negative up here, negative 1, negative 2, negative 3, whatever the negative is, that means the negatives win, the electrons win. So there's more electrons, less protons. If you don't see a charge, that means it's neutral. So if there's nothing written up in the top right corner, you're going to have the same number of positives and negatives. So again, maybe I should have explained all that first before calling on Amanda. So if we have a plus 1, that means we have more protons than electrons.
So it's 18.
So it's right, it's 1 more proton, right? So if this was plus 2, you would have 2 more protons. So that means there would be 17 electrons. Remember, this number can't change. The proton, whatever it is up there, whatever the atomic number, that's what it is. So this is the number that has to be altered. You either add or decrease, add or subtract the number of electrons, depending on the charge. So again, if it's positive, that means there's more pluses than minuses. If you have positive 19 and add that to negative 18, you're going to get a plus 1 overall. Everybody with me here? Okay. Again, the homework's going to practice this. You're going to make mistakes. Sometimes kids start, doing the wrong thing. So they'll say 20 or and I get that, right? We're just going to practice. You'll get used to it. You'll get better. All right, who wants to do F minus 1? Oh, and actually, before I do that again, where did 20 come from? We really want to make sure we get this.
The mass.
Right, 39 minus 19. So these two, again, add up to the mass. This tells me the nucleus is positive 19. But the entire atom is not neutral anymore because we have 1 less electron. K plus lost an electron somehow. Usually the way it does that is it reacts. In a chemical reaction, metals really typically lose electrons. So, all right, over here, F minus 1, Sean. 9, 10, 10. Good job. So now, because it's minus 1, I have to add an electron. It should have 9. When I say it should, a neutral fluorine, so if I was to put it right next to it, so if I just had 19 over 9F with no charge, then it would be 9, 10, 9. If this was neutral, in other words, no charge, I would have 9 positives, 9 negatives. They cancel out to 0. So that's the difference. And if I had K next to this, K would have 19 electrons. Not K plus, just K. So again, there's 1 more negative than positive, so it's negative 1. These two add up to 19. This is a plus 9 on the nucleus. The entire ion is negative 1. Because the charges don't cancel out. The good news is only 3 things to remember. Atoms are neutral. cations are positive, anions are negative. We're going to write all this down. But that's it. There's no other weird like exceptions. It is what it is. It's positive, negative, or neutral. That's it. All right, clean those off. You can come up and use these erasers if you want. And then take out your notes. Kara, how do you feel about me opening a window over there? You're not amped up about it?
I mean,
How about just for a little bit?
yeah, I'm not like cold right now.
Yeah, Dell and I are a little bit more.
Yeah, I wasn't worried about you guys. Well, I can't really roll up my sleeves today. I have a fancy shirt on with cufflinks. Eagle like these cufflinks. It is cool. Why- They're basketball cufflinks. Pretty cool. You guys know about these shirts or no? It's hard to roll them up. I can't like cool off as much as you do. That's the point. All right. Now in our notes, what's the last thing we wrote? This stuff? Yes? No? Did we write the nucleus is positive, the atom is neutral?
We drew like the picture of the.
Oh, right. Okay, yeah. I had you draw a picture of the atom. That's right. All right. So when you guys, let me just go back to that. When you guys drew the atom, a lot of you did something that looked like this, right? Okay. That's called the Bohr model. We're gonna learn all the models in a couple minutes. Each of these rings is called an energy level. There's 7 periods, 1, 2, 3, 4, 5, 6, 7. There's actually 7 rings around each, around the nucleus. So this is only 1, 2, 3, 4. That puts us in period 4, potassium and all of those elements. There's 5, 6, 7 as well, which puts us down lower on the group. We're going to talk about this in a minute. I want to first get down what we just went over, ions. So I'm jumping around a little bit, I apologize, but I wanted to get the ions and the proton, neutron, electron stuff done before we did the model. So we'll come back to that. All right, so cations and anions. Okay. All right, so these are called ions. What the heck's an ion? A cation, I guess you know what I should do is write ions. So ions is like the category. There's 2 types of the category there. Cations is when an atom loses electrons and becomes positive. Anion is when an atom gains electrons and becomes negative. So for example, underneath the cation, let's do K plus 1 electron. Ooh, that's wrong. K yields K plus 1 electron, and then over here we'll do F plus 1 electron yields F minus 1. This may be a little confusing looking at it, but I just wanted to give you like the chemical formula for what the heck we're talking about here, the equation. You alright, Brady?
Yes.
Don't worry, this will.
Is that an H or plus LE?
That's a 1.
All right. That's not what I thought.
That's a number 1. That's a number 1.
I was like an H, but yeah, okay.
That's a 1.
Right there, the plus 1, quote unquote,
Who
looks
writes-
like an H.
No, yeah.
You know what I'm saying?
H looks
Yeah.
like that.
No,
not
you're the first
that.
one, McCoy. The first one.
Yeah.
I mean,
Yeah,
if
it
you
was a
don't
little-
connect your
it was a
H's, it kind of looks like an H.
It's a 1. Moving on. Okay. So potassium, neutral K. Neutral K, meaning same number of protons and electrons. I'm just using these because we just talked about it. If K gets rid of an electron, the way we show that is an E minus. 1 E minus means 1 electron. Well, if K loses 1 electron, it's going to become positive. If F gains 1 negative, E negative 1, here 1 E negative, if it gains a negative, then it becomes a negative ion called an anion. So here's your cation. This is the cation, and then this is the anion. So there's a bunch of different ways you can kind of remember this. I use the example of, or I use you guys with the papers there to help see this, that if we bring an electron in, it becomes negative. Take an electron out, it becomes positive. Don't stress about this like equation. Don't worry about that. If you understand gaining an electron, you become negative, and losing an electron, you become positive, that's really all I care about today. All right, and then hopefully you can apply it to the homework. But sometimes I say, if you get rid of negative things in your life, hopefully you become more positive. So I say that, it's kind of cheesy, but it's true. And that's the same thing here in chemistry, ions. If something negative is lost, then hopefully, or you get rid of something negative, then usually the result is you are more positive. And if you gain something negative or something negative happens to you, then you tend to feel more negative. So that's what I mean with the analogy there is gaining negatives, you are negative. Losing negatives, you become positive. Okay? The part kids get tripped up on is they say, in their head, they say, oh, positive, I'm gaining positives. That doesn't work. You can't gain positive. Those are protons. They're in the nucleus. You're not gaining or losing them. It's only the electrons that can come and go. So you're either gaining an electron or losing it. All right? And if you're a little confused, that's why we practice. We do homework. All right? All right. Questions?
Not yet.
Not yet. So again, if you gain two electrons, it would become negative 2. If you gain 3 electrons, it becomes negative 3. If you lose 2 electrons, it's positive 2. If you lose 3, it's positive 3. So it depends, right? The charge can be more than 1. It just depends on how many electrons you lose or gain. Again, the homework will help with that. And when I give it out, I'll explain a little bit. You know what? Let's do that now. I tend to run out of time. So let me give this to you now and explain what's going on. Because it probably is a little confusing the way it's written. I'll tell you, I'm going to give you one for Nicole. Alright, so if you guys, here, I'll do one with you here, just so you understand what's going on. It's pretty self-explanatory. You find the element, you write the nuclear symbol. I mean, you guys can do this. But if you go all the way, not all the way down, about halfway down where it says potassium ion. Okay, halfway down, potassium ion. Because I want whoever's not here to see this. So what you do, there's a lot going on here. Good thing you have a blank one for tests. All right. So the way you would do this, you go down, you find potassium ion. So you go to K. Does everybody have this out? Take it out. You know what? I should just project it. It's easier. That breeze feels delightful. Not for people with t-shirts. Why are you wearing a t-shirt? It's usually actually I wear t-shirts if I pick hot school. 10. Okay, yep. Fair enough. Alright. Okay, so I'm just showing you how to do this homework and how to find the ions. And then we will learn a little bit about history of the atom, and then we'll move on. Alright. Okay, so what you do is, if it says potassium ion, you go to potassium on the periodic table. Make it nice and big. Okay? So you find K on the periodic table, there's the ion, there's the charge. If you're looking at your periodic table, notice the top right corner of every single box has charges in it. Okay? Na is +1. But if we zoom all the way over here to, let's say, Cl. Cl has 4 charges. Cl -1, +1, +5, +7. A good rule right now, when you're first learning this, is we're always looking at the one on the top. Alright? So, sulfur has 3, chlorine has a bunch. Look at nitrogen. Was that like 7 of them? Yeah, nitrogen has a whole bunch, right? We're just concerned with the -3. So we're only taking the top charge for now. We'll talk about these other ones down the road, but the top charge. So on the homework, if it says nitrogen ion, you would write N minus 3. So this potassium ion, again, how you do the homework is you look up K, and then on the homework, in the box where it says nuclear symbol, you would write K plus 1, 39 over 19, just like the warm-up. So that's what you would write in nuclear symbol, then you would fill in the rest. Mass, atomic number, or protons, neutrons, electrons. Am I making sense? You know what to do? I mean, it may be, you may make mistakes. It may be difficult, but at least if you know what to do, that's half the battle. Whether you get it right, that's a different story. We're good? The only thing I want to mention, besides that, and then we'll move on, is I gave you 3 numbers. Iron 55, bromine 81, and calcium ion 41. Let me show you why that's a problem. If we go to bromine, everyone find bromine, you can look up here or on your sheet, whatever you want to do there. Okay, the mass of bromine is 79.9, which is 80. So Br would be 80 over 35. That's the nuclear symbol from the periodic table. But I'm telling you that the mass is 81. After we get better with this charge stuff, ions, proton, neutron, electron for cations and ions, and we learn a little bit about the history, we're going to talk about these things called isotopes. Bromine has 2 isotopes. What does that mean? Well, if you find bromine naturally in, let's say, a rock or something, right? Bromine's in a compound in a rock, all right? Like uranium. We use uranium for nuclear power. Uranium's found in rocks. It's called uranium oxide as a compound. Just to give you an example. So you can find almost all the elements that aren't white. So the white ones are made in labs, but all the other ones are found naturally somewhere. So if you found bromine naturally, there's 2 types of bromine you could find. Bromine with a mass of 81 or bromine with a mass of 80. That's what isotopes are called. It's the same element, same number of protons, 35, but the number of neutrons is different. This one has how many neutrons? What's 81 minus 35? 46. What about here? 45. So this one has 45 neutrons, and this has 46 neutrons. Bananas. One of my favorite things. Has different isotopes of potassium. Some of the potassium in here is K with a mass of 39. That's that one. Some have a mass of 40. I think 41 is another one too. K41. So in here, there's 3 different types of potassium. It's all potassium, but the mass is a little different. And some kids want to know why, and I don't know. I don't know why. I actually don't know that answer as to why naturally in nature sometimes they have one more proton or neutron or one less. I honestly don't know. So that's what isotopes are called. We're going to learn more about it. But that number, 55, 81, and 41, don't cross it off and write what's on the chart. Use that number. So put 55 as the mass, 81 and 41. All right? So I did that to kind of introduce where we're headed. Now, on the back of this sheet, we are going to learn that stuff later this week. So don't do the back. We will be doing the back at some point. I don't know exactly when. So don't lose this, but don't do the back. All right? Okay. So let's do a practice problem in our notes, one for each ion, and then we'll start with the history stuff. We don't have much time, but we'll do it. All right, so let's do Na plus 1, and let's do S minus 2. All right, I want you to give me the nuclear symbol, protons, neutrons, electrons for each one, and these are the 2 we'll do in our notes, so you have something to look at. Then we'll move on. We have lab today, right? Everybody? Yeah. Finally, I get to have lab with my guys. I feel like I haven't had a real lab in like weeks. Talia, when do I need to, I am gonna get one of these things here, these plants. When do you need the money back?
I don't know,
It
really,
doesn't
she didn't really
say.
give us a date, she
Yeah.
just said go out and try and sell them.
Still don't know what pinched means, but,
The pinched ones, they're wider, they're not tall.
okay. I didn't know there were different colored poinsettias, I thought they were all red.
Some of them are.
When you were little kids, you guys ever put carnations in like food coloring?
Yeah.
I remember, like, I was like second or third grade doing that for the first time, and like my mind was blown.
We did it with celery in like third grade,
Yeah. In what grade?
like third or
Yeah.
fourth.
I thought that was cool. I think there were certain moments, if I think back to grade school, that why I got into science. That was cool. I thought that stuff was cool. Does anyone not know what I'm talking about?
A little bit.
If you take a white carnation and put it in like water with food coloring, it'll turn the color of the,
Oh,
because it
okay,
absorbs
yeah.
the water, and it's actually a lot you can teach with that.
That's how they remember third grade.
I don't remember exactly what grade.
I barely remember what I ate for breakfast.
Yeah, you know, it's funny though, when you get older, there's certain things you'll forget that you know now, and then you'll remember things that you don't know now. It's just funny how your brain works. Anyways, here we go. Na plus, what's the two numbers, Bella? 4311. What about these two numbers? Good. All right. Plus, or how many protons here, Kara? 11. Reagan, how many neutrons?
11.
I guess.
I don't know, I just got like a brain fart.
It's okay. Yeah, 23 minus 11 is 12. So subtract those, and we get 12. All right, Talia, how many electrons? 10. Yes, good job. So I'm going to have to pause for a second. It's plus 1, meaning we have one more positive than negative. It lost 1 electron. That's how I know it's 10 electrons. Good job. Protons. Emma, for sulfur. 16. How many neutrons? Vanessa? 16. Z? 18. So we have 2 more negatives than positives because it's -2. So it gained 2 electrons and became -18. So if you ever get confused with this, which I completely understand, and it will happen, just think about, okay, I need to have a different number of protons and electrons. You just have to remember, think simple math. If it's negative, I'm going to have more negatives. If it's positive, I'm going to have more positives. And then if you need to, write them out. Like actually write out positive, negatives, cancel them out, and see what's going to give you the right answer. +1 left over or -2. So your homework's practicing atoms and ions. All right, we'll be doing more warm-ups throughout the week. So we only got a few minutes, so I'm not going to show the video, there's no point, but stay with me, don't pack up yet. Write in our notes the history of the atom, history of atomic models is a better way to say it, I guess. So let me ask you a question here. Typically, when there's some sort of scientific breakthrough, like, for example, the model of an atom, do you think that takes a very short amount of time by like one person? Or do you think it takes a while over long periods of times over, could be thousands of years, let's say, or hundreds of years, with multiple or lots of people involved? Which one makes more sense? Something like the atom, the model of the atom. Yeah, does it make sense that it would take a long time to figure out what a model of the atom looks like? Why does that make sense? You can't see it, right? I mean, it's not like one person could just look at it and figure it out, right? And usually when things in science are pretty significant, like the rover we just put on Mars, you think one person built that and made all the decisions? Definitely, do you guys even know what I'm talking about? Okay. Yeah, so we just, last week, just put a new one up there. It's going to spend a while up there.
But first day found the sunset, took pictures of it.
Yeah, it's pretty cool how we can do that. But anyways, we'll talk more about that tomorrow. I'm out of time, obviously.